Yeah, our objective for today, I can define and find the slope of a line. Let's read together. One, two, three.
I can define and find the slope of the line.
Yes, we're finding and defining the slope of a line. So what is our concept, everyone? Slope. That's why we have a Freire model. We're starting a new concept, right? So you write in there slope. And hands if you've heard of slope before. Okay, some of you covered that last year. Some of you have not covered that. That's why I'm going to introduce it today. Okay. So before we get started with the lesson, though, I like to introduce it like most concepts in a different approach, just to make sure it's easier to understand. So could you get the lights, please, Kelsey? So, well, everybody knows that I do meet with your math teachers at the high school, right? Yes, we meet, and also we share some of your assessments, like the one that's coming up for the semester. I'm going to share that with them so that they can start having an idea where you're going to be placed, because that's part of your placement for next year. So, at the high school, there was, well, here in Imperial, there was a family that moved here to Imperial, and they were registering at the high school their son. And outside, they were waiting because they needed directions to come to Frank Wright and register their daughter. So they asked me for directions. I said, hold on, let me, I'm okay, you know Imperial? No. Okay, let me get a map so I can show you. So I showed it on my phone. So I showed them on Google Maps, look up. So here it is. With Google Maps, I showed them, okay, here's part of Imperial. We are right here at the high school. And we need to get to Frank Wright, which is over here. Okay? So I said, to get from here, oh, open the door, please. My goodness. Okay. Thank you, Jerry, for taking our time. I am going to finish this lesson even if we stay after the bell, just let you know. Everybody say, thank you, Jerry.
Thank you, Jerry.
All right, here we go. So, so I said, so going from here to here, you're going to take your car and drive through these buildings right here and go straight to Frank Wright. No, I didn't say that, right? So you're like, no. So how do we give directions? So this is how I gave directions. I said, all right, I said, notice here the parking lot is open and the gate is open over here by the softball field, so you can go all the way through here. But let me show you here on the screen. You can see that one of the streets is here and the next one and the next one. I said, so you're going to get in your car. You're going to go 1, 2, 3, 4, 5, 6, 7 blocks up. How many? 7. And I said, make a right, and then you're going to go 1, 2, 3, 4 to the right. How many? 4. All right. So the purpose of me introducing slope like this, because in the past, when your teachers introduced slope, maybe they did show you the correct way, but in your mind, you thought that the line was a slope. So the reason I did this so that you see that the lady does not have to go through these buildings, right? You can't do that. That's why this line is not the slope. You don't do that. What is the slope is when you get from one point to the other and you see the change in y, because this is up and down, right? Change in y, and this is a change in what? X. That is the slope. So check this out. What is the first direction that I gave her? 7 up. So therefore I write 7. How many to the right? 4. And guess what? This is the slope. It's a fraction known as rise over run. You're like, wow. That's why we say the line is not the slope. What's the slope? The change in y over the change in x from one point to the other. Does that make sense? A little bit better? All right, so with that said, in your Freire model, here we go. Slope. And look at the definition. Slope is a constant rate of change in y value and x value between 2 points on a line. Now, does it make sense using this definition? Yes. Think about that line we drew for the lady. We went from point A, which was high school, to point B at Frank Wright. and we saw the change in y and the change in x, and that is our slope. But I wrote AKA, also known as rise over run. That's why we write it in a fraction form. Rise over run. That's why we write it in a fraction form. Or also we call it the slope of the line. So that you remember that it's in fraction form, here somewhere on the side, I want you to write this. Rise over run. You guys see that? And look at the word rise. It's rising. And look at the word run. Bam. Let's go. Okay, and so that it can stick, let's see. Rise over run. Rise represents which variable? When we went up, which variable? Y. So you put a Y here so you remember. And run represents what? X. Now check this out. Look up to the screen. If I put a face here to the letter Y, look at it. Looks like it's going like this. It's rising. How about the X? If we put it, it looks like it's what? Bam! Like a what?
It does.
Running a horse.
Like a dinosaur or something. Yeah. Like, oh, yeah.
Anyway.
Oh.
I have no idea. Anyways, so once again, according to the definition, the slope is the change in y and the change in x between 2 points on the line. Is it the line? Is the slope the line?
No.
No. However, we can use a line to see what kind of slope is represented. So write these examples down. These 4 lines represent a certain type of slope. So write this one, the green one is a positive slope, the red one is a negative slope, the blue one is undefined, and the black one is 0. All right? As you're copying that down, just remember in graphs or in graphing, we always read our graphs from left to right. We always read them from what? Left to right. So watch. I'm going to show you why each one of those is labeled what it's labeled. So now, I know some of you have never left Imperial. Check this out. Or maybe you have friends that have never left Imperial. Now, I'm talking about Imperial, the city. So watch. When you guys go and you finish your education and you leave elsewhere, you're going to find out that in different places they have these apparatus. Check this out. Write your utensils down, look up. These apparatus, and I'm going to approach this one. So if I was to approach this line here, what is the first point I encounter going from left to right? Right here, right? Look up, please. Look at this line. If I'm going from left to right, what is the first place that I encounter on this line? It will be right here. Is that correct? So watch. When you leave Imperial, there's these such apparatuses that if you get on a stair like this, it takes you up by itself like this. They're known as escalators. No, escalators. So watch. Look at this line again. Let me approach it. If I'm going from left to right, the first point I can approach is here, and it takes me up. That's why this is a positive. Look at the red one. If I'm going from left to right, what is the first point I encounter? It's right here. Is that correct?
That's red?
Yeah, it's red. Oh, I know. The projector's kind of off. And then it takes me down, and that is what? A negative slope. Would everybody see that? Now look at the blue one. Look at the blue one. If I approach it, I don't know where's the first part or where's the second point. Since I don't know, that's why this is undefined. Now I approach the black one and I step on it right there on the first step. thinking it's an escalator, but are there any escalators like this? No, they're not known as escalators.
They're sliders.
They're conveyor belts or whatever it is they're called, but they're not escalators. Therefore, since this is not a escalator, as soon as I step on right there, I'm waiting. Am I ever going to move? No, because it's not moving. It's not an escalator. Therefore, this is zero slope. Positive, negative, undefined, and zero. So, in order for me to go completely up, completely down, it has to be what? Constant. It cannot stop. It has to be constant. The same thing here. Everybody understand? So with that said, let me show you some non-examples. Copy these, please. As you're copying those down, think about if these are representation of slope, why aren't these? Why aren't these? You're just thinking about it. All right. Talk it over with your neighbor. Why are these not a representation of slope?
They're not straight. Yeah.
All right. Let's see. Kylene, what do you say? They're not straight lines. That's one thing. Notice these. But what would be a key word according to the definition? Tell your neighbor, what would be a key word according to the definition why these are and these are not? Tell your neighbor, please. What is the key word, everyone? Constant. It has to be a constant rate of change. So what do you think our first hashtag should be? Hashtag constant. That is correct. Oh, wow. Add a couple more hashtags of what you think slope is. Volunteer for this one. Yes, Emily? Hashtag straight line. Yes. Hashtag rise over run. Rise over run. Yep. I got that. No. All right. Write these steps down, please, underneath your prayer model. Step 1, identify 2 points on a line or a table and write the coordinates. Step 2, compute the vertical change over horizontal change. And step 3, simplify. Copy that, please. All right, so we got the steps, and let's go over example number 1. So on your graph paper, on the top left corner, copy this one, example Q. Example Q. It says example Q on the top left corner. You're going to write example Q, identify the slope of the line that passes through -4, -1, and 4, 3. Copy that. You got 20 seconds. Go. All right, it says, example Q, identify the slope of the line that passes through -4, -1, and 4, 3. And you only copy that, right? I'm going to go over this one first to make sure that we understand, okay? Yeah, make sure your graphs are right side up, please, not upside down. Thank you, Jerry. All right, here we go. Look up to the screen, write your utensils down. So, first things first, I'm going to plot the 2 points, -4, -1, -4, -1, and you're just paying attention. 4 and 3, 4 and 3. All right, so think about this. This looks like Google Maps, right? You're saying, not really. Well, imagine that you're in an airplane and you're higher way up and you zoom completely out. Does it look like now the little Google Map? Yes. So now let me show you the line going through those 2 points, nice and straight. You got it? All right, so there it is. There's my line. Pay attention, please. All right, so to give directions, which is the first point from left to right? Is it this one? No, from left to right, the first one is this one. So we're going from here to here. Let me find my slope. Here we go. So look up, please. So to get from here to here, I count steps up. I go 1, 2, 3, 4 steps up. Okay? I make a right turn and I go 1, 2, 3, 4, 5, 6, 7, 8. Therefore, check this out. From now on, instead of writing slope, I want you to use the letter M for slope. And we know it's a fraction, right? Rise, what was my rise? 4 was my run, 8. And the last step of the steps that you just wrote down says simplify, didn't it? Can we simplify this to lowest terms? Which is 1/2. Copy that, please. And that's how we find our slope. Copy that. All right. Now check this out. Look up, please. Now, according to the definition, it says 2 points on a line. Does it matter what points? No, as long as they are on the line. To prove it, I'm going to pick 2 points from that line. Look up, please. 2 other points. Look up to the screen. First point, I'm going to use, I'll use this one. Plot it on yours. This is 8, 5, 8, 5. And the other one, I'm going to make it that it's all the way over here. -10, -4. -10, -4, and 8, 5. So if we go from this point on the far left to this point on the far right, we need to go steps up. Is that correct? So let's see. I go 1, 2, 3, 4, 5, 6, 7, 8, 9 steps. So that's 9 for the right. I make a right turn and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 for the run. So what is my slope for this one? M equals, what is the rise? What is the run? 18. Can we reduce this? And what does that give us? 1/2. Is the definition correct? Yes, because it's a constant rate of change. That's why we're going to have the same slope anywhere between 2 points. You understand? Let me go back to the fair model so that we understand what we're looking at. What kind of line, what kind of slope does this line represent right here? A positive slope. Let's look at the line that we just graphed. Does it look something like this?
Yes.
Was it a positive slope? Yes. With that said, go to the next graph, copy example super cube. You don't need to copy the instructions anymore, just copy the 2 points, -2, 6, and 2, 3. Copy those, plot your points, graph your line. You have an index card so it can be nice and straight, and find me the slope between those 2 points. Copy and go. Should be just about done. Yep. 10, 9, 8, 7, 3, 2, 1. All right, check with your neighbors, see what they got, please. All right, let's see. I'm going to go over this to make sure that we got the correct thing. Here we go. What is my first point? -2, 6. -2, +6 is about right there. Check yours. See if you have it right there. Second one is 2, 3. 2, 3, right there. Hands if you got that up to right there. Okay. From there, you graph your line using your awesome index card. Yes. So check this out. I'm going to graph my line, something like that. Let me straighten it up. Something like that, yeah? There it is. All right, so let me count. Now pay attention to this part. Look up. Going from left to right, am I going up to get to this point? No, now I'm going which way? 1, 2, 3 steps down. So if I went down, It's a
Negative.
-3. That is correct. And then we turn right and we go 1, 2, 3, 4. Therefore, my slope is, what was the rise? -3. And what was the run? 4. Hands if you got that. Good. Now, what would happen if I pick other 2 points on that line? What's going to happen once we simplify? What kind of slope are we going to get? -3/4. Do I need to show you that? No, everybody understands that it's a constant rate of change, yes? Now, why is it a negative slope? Well, let me go to my Freire model again. Let's see. Look at this line is representing the positive slope. Look at this one. What is this one? Negative slope. Let's see these lines. Positive slope. Look at this one. Negative slope. Does everybody see it now? All right? Show me with your fingers how comfortable you are right now understanding how to get the slope from 2 points. 5, 5, 5, 5, 5. All right? And a 4. Okay.
Yeah.
Turn your paper over, please. And in the back, copy this. You have your index cards. Doesn't matter what size, just copy that. Once you copy that, I don't need any tallies or any numbers. Just make it look like this. And then I want you to place 2 points. One here and one there. They don't have to be exact, but just something that looks similar to mine. Is everybody there? Everybody ready? All right, question. Look at these 2 points. Which is my point 1?
No.
Jesse, this one? Yes? That is incorrect. If we go from left to right, what is my first point? This one. That's because you weren't paying attention. So this is point 1, and this is point 2. Okay, label that. Okay. Now check this out. I'm going to write the coordinates for point 1 right here. Point 2. Point 2 has a coordinate x and a coordinate y. Is that correct? How about point 1? Point 1 also has coordinate x and coordinate y. Write that down, please. You're saying, they look the same, Mr. Q. Yes, I'm trying to make a point. So here we go. If this is point 2 and this is point 1, in order to understand which one is which, check this out. Point 2, we label it like this. X sub 2, y sub 2. So therefore, what am I going to label this one? X sub 1, y sub 1. What if we had a third point? X sub 3, y sub 3. That's how mathematicians use different labels for different points and so on and so forth. So here it goes. I'm going to stretch your noodle a little bit, but I want to get through this part because this is how you're going to understand the concept of slope. Focus, please. Write your utensils down and look up. You'll copy everything at the end. Look up, please. Here it goes. So this is point 1. What is my x value for point 1? X sub 1. That is correct. What is the y value for point 1? Y sub 1. Okay. How about for point 2? What is my x value? X sub 2. How about my y value for point 2? Y sub 2. Okay. So far so good, right? You'll copy at the end, yes? Okay. All right. So given these values, I can find my slope. M equals, I'm going to leave space here, and we know it's rise over run. So here's my fraction bar. So check this out. Look up, please. I'm going to use numbers right now just to... Are you guys okay? You guys... Yes? Yeah. Oh, my goodness. Writing utensils down. You'll finish copying at the end. Didn't I say that? Okay. All right, here he goes. Therefore, I'm going to use numbers to illustrate what we do, but then I'm going to take away the numbers. Here we go. Look up, please. And I'm going to stay quiet. Let's say this was 2 and this was 8. Let's say this was 6 and this was 10. I want to get from here to here. Now that I have numbers, to get from here to here, I need to go rise. Is that correct?
Yes.
Tell your neighbor, what is my rise, please? Okay. And then from here to here, what is my run? Tell your neighbor, please. All right. So, how do we get this? Look, please. Are we there so far? How do we get this? Are we there so far? Does everybody agree with that? Okay. However, I don't want it written with numbers. I want you to think outside the box and think about the labels that we started with. To get this one, we said we do something with these, yes? And if you saw them written here, you would see them, right? Everybody see that? So watch. To find the distance from here to here without using numbers, I would write what? Who sees it? Y sub 2, what else? Minus y sub 1. Okay. How about to find this one, the run? What do we write? X sub 2 minus x sub 1. And guess what? This is the slope formula. Copy that, please. You're saying, what does that help us for, Mr. Q? Well, let's find out. Underneath that, you're going to write example mega Q. Write find slope between 5, 8 and give me a number. Yeah, 2, 3. So the formula for the slope, for finding slope, is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Formula for the slope is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Formula for the slope is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, why is that important? Because there's going to be some problems that they're going to ask you. Find the slope between this and this without graphing. Let's find it right now. Here we go. Check this out. First of all, how many points do we have? 4. 2. 1, 2. Let's label these. This is my first one because we're starting from left to right, yes? X sub 1, y sub 1. So what do I label this one? X sub 2, y sub 2. Next, I'm going to write my formula, but without the labels. Watch. M equals fraction bar, minus, and minus. So, what is y sub 2? 3. Minus, what is y sub 1? 8. Okay. What is x sub 2? 2 minus, what is x sub 1? 5. And you're like, what is this? What is 3 minus 8? Negative 5. What is 2 minus 5? Negative 3. Can we simplify that a little bit more? Yes, what is negative divided by negative? Positive, and we leave it as 5 over 3. Copy that, please. And that's how you find the slope of a line without graphing. using the formula. Bam, right on the money. Let's go. So our home plate for tonight is found on pages 176 through 178 only. Kelsey, I have your page printed. All right, there is tutoring today. If I don't see you, have a good one, guys. Enjoy your home plate. See you guys tomorrow. Before we leave, really quick, how comfortable do you feel with slope? 5 being the greatest, 1 being the lowest. Got some 4s, 5s, 4s, 5s, 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 5s. All right, have a good one, guys. See you guys tomorrow. Bye.